Hi everyone, in this video I'm going to take the June 2024 Algebra 1 Regents, just the free response section, and I'm going to do it specifically using the Numworks Calculator so that you can see how this calculator can support you on the various free response questions. What I'm going to do on each question is I'm going to show you first how you could verify the answer in your calculator for partial credit, and then I will follow that up by doing it the full credit way by hand, and we will make sure as we go at the end that my work matches what I had checked in the calculator. So beginning with question 25. Question 25 asks me to solve 5 parentheses x minus 2 is less than or equal to 3x plus 20 algebraically. So before I do this by hand, it is possible for me to get partial credit just by looking this inequality up in my grapher. I'm not going to use equations because this is an inequality. It is not an equals. So for any inequality, I want to use my grapher. In grapher, I can enter the inequality exactly as I see it. Notice that we have less than or equal to. Less than or equal to, I can use this toolbox button, the run on the upper left. So I'll click that again, right next to backspace where it says paste in orange. Think of that as your toolbox. We can get our less than or equal to right there. 3x plus 20. So I've entered my inequality into the grapher. And now if I go to my graph, what I will notice is that I have a solid boundary. My boundary is at x equals 15. I can see that at the bottom of my screen. So the boundary is at x equals 15. And then my shading is below x equals 15. So I can expect that my final answer should be x is less than or equal to 15. And I can put that at the bottom of my paper right away. At this point, I have earned half credit because I have the correct response. I just do not have my algebraic strategy shown. So now what we're going to do is we're going to do out the work, and we're going to make sure that at the end we get all the way to that solution. So if I have 5x minus 2 is less than or equal to 3x plus 20, first I'm going to distribute over here. That gives me 5x minus 10 is less than or equal to 3x plus 20. And now what I would like to do is I want to collect all of my my linear terms on one side, and I want to collect my constants on the other side. It doesn't matter which one is which as long as I am consistent. So if I want to collect my constants on the right, then I'm going to add 10. Adding 10 cancels out my negative 10, so I am left with 5x is less than or equal to 3x plus 30. So now all my constants are on the right side. I'm going to move all my linear terms to the left side. So I have my linear terms on one side, my constants on the other. So I have that 3x. I'm going to subtract it from the right, leaving me with 2x on the left expression, less than or equal to 30. And then finally, to finish this out, since I have 2x, I just want 1x. So I'm going to divide both sides of my inequality by 2, leaving me with x is less than or equal to 15. You might think, oh, we never flipped our sign, right? We divided by a positive number, so I would only change the direction of this inequality if I was dividing by a negative. And then what's nice about this is at the end of my process, I have gotten the same answer that I got with technology. I've boxed my solution, and I can feel confident that I'm correct because I have determined this answer 2 different ways, which makes me quite confident that I am right. Moving on to question 26. Question 26, given g of x equals x to the third power plus 2x squared minus x, evaluate g of negative 3. So in this question, we are given a function. We are asked to evaluate. We are not solving. This function is a rule where we have lots of inputs that give us lots of outputs. They gave us a specific input, and all we're going to do is substitute that in to find the output. So first, I'm going to copy my function equation. But everywhere I see an x, I'm going to leave myself a empty parentheses. So I've copied my function equation, but instead of all the x's, think of it like I've left myself blanks, and I've left all those blanks in parentheses. Now to evaluate g of -3, I'm going to replace all those x's with -3's. -3. You'll notice in this step we have some double negatives, we have negatives to the power of 2, so this is why it's very important to write it out with parentheses first, because those parentheses are going to make a difference in our final answer. At this point, if you have written this out, you have already earned 1 out of 2 points. So it's very important to write this out, even if you're going to evaluate it in your calculator next. So this has earned me 1 out of 2 points. And then to evaluate it, I'm going to use calculations, because we're not solving for x, we're just evaluating an expression. I'm going to use calculations to figure out, essentially to simplify this whole thing here. So I have parentheses -3 to the power of 3 plus 2 parentheses -3 squared minus parentheses -3. And then at this point, I'm going to just do one quick double check. I'm going to make sure I typed everything exactly how it's written, that my writing matches the function that they gave me. Everything looks good. I'm going to hit OK. G of -3, if I simplify that, gives me -6. So I have evaluated my function for the input -3. I'm going to box that as my final answer. Question 27, given the relation r is equal to, and then they gave me a set of points. First point is -1, 1, second point is 0, 3, third point is -2, -4, and the fourth point is x5. State a value of x that will make this relation a function. Anytime I am asked whether something is or is not a function, all that I need to remember that is that a function is any relationship where each input must have exactly one output. Each input must have exactly one output, the same way that each person has one birthday. No one has 2 different birthdays, and everyone has a birthday. So every x value should go to one y value. What that means is when they say state a value for x, I want to say x equals, then I can choose any number that does not already have an output. So -1 is taken, 0 is taken, -2 is taken. If I state any other number, then this relation is still a function. So maybe I'm going to choose 4, right? There is no output yet for 4, so if x is 4, then the input 4 goes to the output 5. And then to explain this, I want to use this exact definition. The verbiage is very important. So I want to say if x equals 4, then each input has exactly one output. Therefore, this is a function. Awesome. Question 28. This is a slightly less common question. This is more likely to show up in something like multiple choice. But if this does show up in free response, you want to treat this kind of like a logic puzzle and just take one piece of information at a time. In a two-way table, the things that matter is that each row adds up to a total, and each column adds up to a total. So let's take this one piece at a time. First thing they tell me is that this is a survey of 150 students. That means my grand total is that there are 150 students. I'm going to put that in the lower left because that is where all of the students are. And then looking at my table, I can see that these students are going to be divided up in two ways. The first way they were divided is between social media or no social media. Second way they were divided was between video games or no video games. So for each thing that they tell me, I'm going to work backwards from here. First thing they say is it was determined that 2/3 of the students play video games. So that means I'm trying to figure out what goes here. How many students play video games? If 2/3 of the students play video games, 2/3 of 150 equals 100, right? If I can't do that in my head, I could multiply that here. 2/3 times 150 gives me 100. So I know that 100 students play video games. If 100 students play video games, and there are 150 total, then 150 minus 100 tells me that there are 50 students left. Those must be the ones who do not play video games. Right? There's no third option, so the difference must be that. Next thing they tell me is of the students that play video games. So what that clause means is we only care about this column. So if we only care about this column of the students that play video games, 85 also use social media. If they play video games, they also use social media, then I'm looking for this box. So that means there are 85 students here. And now I can see I could do subtraction again. My 100 students, 85 of them play video games, or 85 of them are on social media. That means that the other 15 are not on social media because we needed a total of 100. And then the next thing they tell me, of the students that do not play video games, so now I'm looking at this column, 20% do not use social media. So for percent, I need to remember that 20% means 20 out of 100. So 20 out of 100, and I'm talking about the second pink column, so I'm going to do 20 out of 100 times 50. So 20% of 50, let's see what that is. 20% of 50 is 10. So that means 10 students do not use social media. If they do not use social media, that is this row down here. I can do 50 minus 10 to determine that 40 of them do use social media, right? And now if I want my totals across on the right side, then I can just add up my rows. I have 85 students who are on social media, then I have another 40. So in total, I have 125 social media students. And for no social media, I have 15 and 10, so I have a total of 25. And that looks nice because my 125 and my 25 add up to my 150. So everything in this table is adding up cleanly. Okay. So again, this is a slightly less common Regents type question, but just take it one piece at a time and remember that your rows and your columns need to add up to an appropriate total. Now on to one that is a little more common. This one's common, it's a little bit challenging, especially since it's only 2 points. This can feel like a lot of work for 2 points. So they're saying use the method of completing the square to determine the exact values of x for the equation x squared plus 2x minus 30 equals 0. So one thing I want to notice is I have this word equation. If I have an equation and they are asking me to determine the values of x, they are asking me to solve an equation, right? I want that to be a little green flag in my head. That means in my calculator, I'm going to be able to look up the solution so that I know from the beginning what my end goal is. So even before I use completing the square, I can put this equation into the equations app. So I can put this equation into the equations app. I can click solve this equation and it's going to tell me my two final solutions. What's nice about this is sometimes in more complicated algebra, we feel like we are finished before we have actually completed the job. So I can say one of my solutions, so x1 is -5 minus radical 55. The other solution is -5 plus radical 55. I know this is my end goal, so I can box it on the bottom of my paper. And that can be a check for myself of have I shown this process correctly. If I just put the solution and I don't do the work, I am only getting 1 point. So I don't want to just rely on the equations app to do the test for me, but it can remind me, okay, that's my finished goal. Now I'm going to do the work to get there. So in order to complete the square, we're starting with x squared plus 10x minus 30 equal to 0. When we are completing the square, unlike the quadratic formula or factoring, we want to move the constants to the right side. So we do not want this equal to 0. We want to move this 30 over because we want all of our quadratic and linear terms to be set equal to the constants. So I have x squared plus 10x equals 30. And then at this point, completing the square means I want to take those quadratic and linear terms and arrange them into a square formation. So I can imagine I have an x squared, right? That is x by x. And if I have 10 linear terms, if I'm going to make a square, I'm going to need to put 5 of them over here and 5 of them down here. So my square is going to be x plus 5 times x plus 5. So that is going to be x plus 5 quantity squared. However, because I don't have my constants, I have this empty corner. In this empty corner, I am missing 5 times 5. So I'm missing 25. Since I'm missing 25 in that lower corner, I'm going to say I have x plus 5 quantity squared minus 25, because the 25 are missing. And I know this entire thing is equal to 30. Because those are the constants that I moved over from the beginning. So in that step, I have completed the square. This is one example of where if we had not solved it at first, we might feel like we're finished. We just accomplished something, we completed the square. However, we have not gotten all the way to having x alone. So to get x alone, now I'm going to use inverse operations. First, I'm going to move these constants over to the right-hand side. So I have x plus 5 quantity squared equal to 55. And now, in order to undo the square, right, to do the inverse of a square, I am going to take a square root on both sides. So when I take a square root on both sides, that is going to leave me with x plus 5, right? I've gotten rid of the square. But on the right-hand side, I need to put either the plus result, or I can also end with x plus 5 equals negative radical 55. So anytime we introduce a square root ourselves, we need to include a plus or a minus, because both things are possible solutions. Now I can see I'm almost at my final answer. I just need to get rid of that positive 5. So I'm going to do an inverse operation. I'm subtracting 5 on both sides of these equations. That leaves me with x equals -5 plus radical 55. And then subtract 5 over here, subtract 5 over here. X equals -5 minus radical 55. And then I can see I have successfully made it to my solutions. So I have the solutions from the calculator, and I also have complete and clear work demonstrating that I understand the strategy to get there. Question 30, factor 20x to the third power minus 45x completely. When you see factoring in for your response, it is almost always going to have a greatest common factor. We want to look for a GCF first, because factoring for your response needs to be 2 steps. And it's very difficult to write a factoring problem that requires 2 steps if there isn't a GCF. So what we're going to look for first is our GCF. We want to ask ourselves, what do both of these terms have in common? So the first thing that I see is that both of these terms have a x. So I'm going to say my GCF has an x in it. And then I want to ask myself, what do the numbers 20 and 45 have in common? You might notice right away that they are both multiples of 5. But if you don't notice that, what you can do is you can make a list of the factors of 20 and 45 and then just look for whichever one is the largest. So 20 can be divided by 10, it can be divided by 4, it can be divided by 5, 2, and 1. 45 can be evenly divided by 15, by 5, by 9, by 3, and by 1. So these are all numbers that divide evenly into 20 and 45, and I can see that the largest one, the greatest one that they share is 5. So I'm going to say my GCF is 5x. Therefore, if I want to factor out a 5x, I'm going to imagine that I'm dividing both terms by 5x. I'm going to put the 5x in front. And then I'm going to figure out what is 20 divided by 5, that is 4. What is x cubed divided by x, that is x squared. 45 divided by 5 is 9. X divided by x is 1. So if I factor out a 5x, I'm left with 4x squared minus 9. At this point, once you've gotten your GCF, you have earned half credit. So even if you can only get the GCF and then you get stuck, always try to factor out your GCF in order to get some points on the factoring problem. Next step is I might notice that this is a difference of squares. So 4 is a perfect square, x squared is a perfect square, 9 is a perfect square, and they're connected by subtraction. So to factor a difference of squares, I'm going to keep my 5x, and then 2x times 2x gives me 4x squared. Positive 3 times negative 3 gives me negative 9. And 6x minus 6x cancels out to 0, so I end up with no linear term. So my fully factored form is 5x times 2x plus 3 times 2x minus 3. Notice that sometimes we have factored and then continued on to solve for x. If they only ask you to factor, make sure to box your factored form. Do not keep going and solve for x, because then you may get points deducted for not understanding the difference between factoring and solving. If you're only asked to factor, then your answer should be the factored form. Now we're moving into 4-point questions. So question 31 asks us graph the following system of equations on the set of axes below. They gave me two equations, y equals x squared minus 3x minus 6, and y equals x minus 1. And then they said state the coordinates of all solutions. So what I'm going to do here is I'm going to go to my grapher. And for this one, I'm going to demonstrate some of the grapher features that might help you navigate any type of graph. So first thing is I'm going to put in my two equations. So I can use alpha to type my y equals x squared minus 3x minus 6. And then what you'll notice is this says parabola. If you go over to your 3 dots and click details, it will tell you your vertex. So that's some nice information. That's also going to be nice and visible on the graph. But if you want to know your vertex right away, you can get that in the 3 dots. And then my second equation was y equals x minus 1. So I have both of my equations entered into the expressions tab. And I'm going to take a minute and make sure that I did not type anything incorrectly. If I typed anything incorrectly, then that's going to mess me up. One other thing that you might notice is that this is going to color code for you. So see how the first equation is in red and the second one is in blue? It can be helpful to label that for yourself right here. so that later on, if you're on a different screen, it's always going to be red and blue, and then you can keep track of which one is which. So I'm going to just write red and blue right there. Now, I'm going to head to graph. You'll notice that if I'm looking at this graph, this set of axes does not match the axes I have on my paper. So I can scroll around, like I can do things like this. I can go left and right. I can use the up and down buttons to switch between the two functions. But you might want to, like, since they gave us a specific axes, there's a couple ways that you can control what you see on your window. One way is you can scroll up to the top here. If you select auto and hit OK, then your calculator is automatically going to select a zoom that it thinks shows the important information. So now I see all the important information. However, I still do not see the exact same size grid as I have on my paper. So on my paper, if I count this out, I'm going to see that this goes up to 15 and down to negative 15 on both axes. If I want to make my window identical to that, I can go to axes, and I can dictate the values of x and the values of y. So if I go into values of x, I can say I want you to show me from negative 15 to positive 15, because that's what my paper does. Then I'm going to go down and hit confirm. And I'm going to make the same decision for y. Show me from negative 15 to positive 15. Hit confirm. Back on here, I'm going to hit confirm again. Now, these axes, even though it's not like shown exactly like the screen, this is showing me all the same detail that they gave me on paper, so I know that I have the same information. To plot my points, I have two options. I can either scroll around on the line itself like this. This is going to give me some points I can plot. And then I can switch graphs using up or down. So I can scroll around the graphs. But you might notice that when you scroll around, it's giving me a lot of kind of messy decimals. So what I might do is I might get the key points. So it'll jump to the minimum. I'm going to graph that key point. 1.5, negative 8.25. So positive 1.5, 1, 2, 3, 4, 5, 6, 7, 8.25. So I've got my vertex right here. I could maybe do the y-intercept, which it'll label for me 0, negative 6. I've got a 0. That 0 is a little messy. These are messy decimals. But if I would rather see things like counting by a consistent value, then sometimes your table is more useful for plotting points. So now I'm going to go over to the table. And what you'll see in the table is, by default, it's going to show me x values from 0 to 10. But I already know that I want some more x values. So what I'm going to do is I'm going to make my table the same x values that I see on my paper. So if I go to set the interval, I can choose where x starts and where x ends. So on my paper, x starts at negative 15 and x ends at positive 15. That is the size of my graph. And I'm going to, step means how much do you want it to count up each time. So I'm going to say, yeah, start at negative 15, go up to positive 15, count by 1 each time. I want to see all of those values in my table. I might not need them all, but I want to see them all. Now, I'm not limited to 0 to 10. I have all of the relevant values. And what I want to do is I want to plot every point that fits on the graph. So starting with my red graph, the parabola, I'm going to find the first point that would fit. So I'm seeing that these y values are too large. They're going to be off my grid. But once I get to negative 3, the point negative 3, 12 is going to fit. So I'm going to start there, plot all of them. So I have negative 3, 12. Then I have negative 2, 4. Negative 1, negative 2. 0, negative 6. I've already plotted that one. 1, negative 8. We got our vertex from the grapher screen already. 2, negative 8. 3, negative 6. I just caught the fact that I plotted my y-intercept wrong. There we go. 3, -6, 4, -2, 5, 4, 6, 12, and then 7, 22 falls off my graph. So I've plotted for a parabola, you want to plot every single point that fits on your grid, and then you want to make sure you also have your vertex, because the vertex is very important, even if it's a decimal. Another thing you want to check for is notice that my parabola is symmetrical. So the first time I graphed it, I made that little error where I plotted this point in the wrong place. I noticed that it was off when I plotted this one and they weren't lined up. So when you plot your parabola, you should have this nice symmetrical situation where you have a mirror image across your axis of symmetry. So check that you have that nice symmetry. If not, you want to go back and double check those points. And then I'm going to connect my points with a nice curve. I'm going to make sure that my curve continues all the way to the edge of the grid. And I'm going to label it with the equation. So I've graphed my red graph, and now I'm going to graph my blue one. If this table is kind of like confusing you that we still have the red one in the way, excuse me. What you could do is you could go to equations and you could delete the parabola so that we just have the line left. So now if I go to my line, since this is a straight line, I could start at -14, -15. And then I could plot every single point if I want to. But you might start to notice that, like, okay, this is going to be lots and lots and lots of points. And so you will have a ruler on the exam. If you're plotting a straight line, what I recommend is don't just give yourself some points in the lower left and then connect those. Plot at least 3 points that are kind of spread out. So if I plot -3, -4, and then I plot 2, 1, and then if I plot one in the upper left, like 10, 9, or I'll go even a little farther, 15, 14. Now I have some points that are spread out, so when I connect them with my ruler, I know that I'm not going to kind of veer off the path. So if I have some things all the way across for a straight line, that's going to help me make sure that I have my line in the right position. And I'm also going to label this one. So at this point, things I would highlight are make sure you're plotting plenty of points very precisely. If it's a parabola, plot every point that fits on the grid. If it's a straight line, plot at least 3 points that are spread out and then connect with a ruler. If you're plotting a parabola, make sure to include your vertex, even if it is a decimal. And the way that you can get these points in the table, once you're done kind of looking at your graph, is you can set the interval to whatever interval you want, and your table will show you that interval. So let's say you were doing a different graph that for whatever reason you wanted values between 65 and 92, right? Maybe this was like a word problem and it was temperature, and so you're going from 65 to 92 on the x values. You could hit confirm and it'll show you that in your table. So your table can be whatever interval you want. You just need to choose it and go from there. I'm going to reset to 0 to 10 or maybe -10 to 10 so that when I come back in the future, I don't have something crazy. Awesome. Beautiful. So we have graphed our system. And then what they're asking me is state the coordinates of all solutions. For this, what I want to remember is that the solution of two equations is the intersections. If I'm going to get credit for all solutions, then I need to put both solutions which I can see as these two intersections on my paper. So the first intersection is -1, -2. The second intersection is 5, 4. They just said state, so I don't have to explain, I don't have to justify, but I do need to put both if I'm going to put credit. At this point, now I've achieved full credit because I have both graphs graphed precisely, they are labeled, I have both solutions, and I have all key features done on my graph cleanly. Linear regression, question 32. So this says the table below shows the amount of money a popular movie earned in millions of dollars during its first 6 weeks in theaters. Write a linear regression equation for this data set, rounding all values to the nearest hundredth. State the correlation coefficient to the nearest hundredth, and state what this indicates about the linear fit of the data. So if we are doing linear regression, what's nice about this calculator is it has its own app just for this type of problem. So regression means we want a line of best fit, which means we're going to go to the regression app. So if we're in the regression app, we're not going to statistics, we're going to the regression app. That's the only thing that this app does, is it calculates regressions. What I'm going to do is I'm going to type in my x values in the first column. So I put my weeks in the first column, and then my y values, the dollars earned, I'm putting in the second column. So 185, 150, 90, 50, 25, and 5. So I've entered my data in, and then I'm going to want my calculator to show me a line of best fit equation. All right. So what's nice about this is we can look at how the data looks by going over to graph. So if I go over to graph, then I can see all that data I entered in, and I can see the overall trend. So if I was asked about this trend, I could say, oh, as the weeks are going by, I can see that the movies are earning less money, right? If I was asked to interpret it, I can see that trend with my own eyes right here. To see the actual results, what I'm going to do is I'm going to hit OK. And you can see that my first option is linear, right? We want a linear model because they asked for a linear regression equation. All these other regressions are things you will need later on in life, but you do not need them yet in Algebra 1. So I'm going to hit OK. That's going to give me linear. I'm going to hit OK again. Now I see the line of best fit, but I don't see the equation yet. So I'm going to hit OK a third time, and it'll give me the equation of that line. So again, I'm just going to do that over from the start. If I have my data, then I can go over to my graph. Or actually, I'm going to re-delete the data. So let's say I have my data. I deleted this. I just finished entering my data. I go to my graph. I see a scatter plot. I'm going to hit OK, OK, OK. So I'm literally going to go to the graph, hit OK 3 times, and that will tell me my regression equation. I will need to round it on my own. So they said to round to the nearest hundredth. So here our equation is negative 37.57143x. I'm going to round that to the nearest hundredth, so negative 37.57x plus 215.6667. That's going to round to 215.67. So they will give you the equation. All you need to do is round it accurately. And then the correlation coefficient is the R value. That is what tells us how strong this fit is. So right underneath the equation, they tell you the correlation coefficient. I'm going to copy it, but once again, all I need to do is round it. So if I round this to the nearest hundredth, that would be negative 0.98. And then what does this indicate? What this indicates is that we have a very strong fit because R is close to -1. It's specifically a strong negative fit, but What's very important is that we say that it is strong because the Regents always gives strong fits. So the fit of the data is strong. If you are asked to explain what that means in context, then what you can do is you can go back and look at your graph again. And you can just describe overall what's happening in this story. As the weeks go by, the money goes down, right? You don't need to be you don't need to go in depth, give cause and effect. You can just describe what's the date, what happens as it goes by. Are the numbers going up or are they going down? But the very important word to provide is that the fit is strong. (33), we're asked to use the quadratic formula to solve the equation 3x squared minus 10x plus 5 equals 0 and express our answer in simplest radical form. All right, we have another equation that we're solving. So what I can do is before I use my quadratic formula, I can check what my final answer is going to be. So 3x squared minus 10x plus 5 equals 0. If I solve this equation, now I know what my end goal is, so I know what target I have in mind. I'm going to put this on the bottom of my paper. X equals 5 minus radical 10 all over 3, and x equals 5 plus radical 10 all over 3. So I know eventually where I should end up. You can call it x and x, or you can call it x1 and x2. Either way is fine. So I know I should end up there, and I can see that I'm going to have a discriminant of 40. Now what I'm going to do is I'm going to do my quadratic equation. So first of all, the reference sheet has the quadratic formula for us. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Right? Your reference sheet has that for you, so make sure you have it correctly. And because my equation is already set equal to 0, I am ready to identify my a, my b, and my c. So my a here is positive 3. My b is negative 10. Make sure you don't forget that negative because it's minus 10x. And my c is positive 5. What I'm going to do now is I'm going to copy the quadratic formula, but just like I did with functions, I'm going to leave a parentheses everywhere I have an a, b, or a c, so that when I insert these into the formula, I know that I am doing so with parentheses everywhere I need them. So I have my formula negative blank plus or minus blank squared minus 4 blank blank all inside of a square root all over 2 blank. Right? Now I can take my a value, my b value, c value, and insert them in the correct positions. So my a, the 3 is going to go where the a's are. The negative 10 will go here. The 5 will go in the C position. If I got here and I did nothing else, I have points for a correct substitution. I have my final solution on my page. This is great. I have the beginnings of the quadratic formula. I have my final solution, but we want to show how you would take this formula and simplify it to get to that solution. So in order to do that, I'm going to think of this formula first as kind of like 3 chunks. Negative 10 is just positive 10. Plus or minus, then we have this big mess inside the square root. So inside the square root, I have, and I can use calculations to help me out this with, negative 10 squared minus 4 times 3 times 5, right? So all of this is inside the square root. I can see what that is. That would give me 40. So negative 10 squared is 100. 4 times 3 times 5 is 60. 100 minus 60 gives me 40. So that means in this square root, I have 10 plus or minus the square root of 40. And I know that 2 times 3 is 6. So now I've simplified this to 10 plus or minus 40 all over 6. the way that this is going to become 5 minus radical 10 all over 3 is my radical 40 my square root of 40, we might notice that that has a perfect square in it. So the square root of 40 is the same as the square root of 4 times the square root of 10, right? Because we know eventually we're going to get down to square root of 10, not square root of 40. And the square root of 4 is just 2, because 4 is a perfect square. So that square root of 40 I could replace with square root of 2 square root of 10. To radical 10 over 6. And that is how we end up at our final answer. 10 divided by 6 can reduce to 5 over 3. 2 divided by 6 can reduce to 1 over 3. So 10 plus or minus 2 radical 10 all over 6 reduces to 5 minus radical 10 all over 3. What we've done here is we know we have the correct final simplified solution. And we've shown to the best of our ability how we can enter the values in the quadratic formula and simplify them to get there. All right, 34, we have another grapher question. So on this one, we have graphs of inequalities. Inequalities, that immediately tells me I'm going to have shading, so I'm going to have a solution set. I have two inequalities. I'm asked to graph them on the axes below, and then state a coordinates of a pair that is a solution. So if I go back to grapher, even before I clear this line, I can set my axes to equal a 10 by 10. Because it looks like this graph on my paper is 10 by 10. All right, I think I did that too fast. We might have to go back. But 3y plus 2x. Remember, we can use toolbox for less than or equal to. Is less than or equal to 15. And then y minus x is greater than 1. Awesome. So I have my two inequalities. The top one is red, the bottom one is blue. If I go here, then I can see both of them. So things I want to highlight are, notice that my red one is a solid boundary. My blue one is a dashed boundary. I'm going to write that down just so that I don't forget it. And that the shading for both of them is on the left-hand side. So the blue one that is above, the red one that is below. To graph the red one, I am going to, because these are inequalities, I cannot go to my table, right? But I can scroll along the line. But you might notice that these are giving me kind of like decimals along the line. If I want some whole numbers instead, what I can do is I can type a whole number. So let's say 5. Hit execute, and it'll tell me the y value. So if I put 5, I got a decimal. Let's try 6. The 0.61 is a whole number. And then I can kind of jump from there. I see I have 3, 3. 0, 5. -3, 7. So I found a number of points along that boundary. I might notice it has a slope of -2/3, and I can kind of continue that. And then I'm going to connect them with a ruler, and make sure that I create a solid boundary, like this. And then the red one is shaded in this direction, so I'm going to shade in the same direction. So I know my solutions for the red inequality are down this way. And before I move on, I'm going to label this with which equation it is. It's very important that you label each one. To jump to the other boundary, I can use these up or down arrows. So if I use the down arrow, now I can get some points along this boundary. So I have -3, -2, -1, 0, 1, 2. Then I might notice that this has a slope of 1, and I can continue extending that. However, when I connect this line, you do not want to do what I just did. You want to make sure that if it is dashed, I am making it dashed on my work. So I'm showing a dashed boundary like this. And then I'm going to shade in the direction where the blue is shaded. So I see shading over here. And I'm going to label that this is y minus x is greater than 1. So I've graphed both equations. I've done so precisely. I make sure I have exact points along the boundary. And before I move on, I want to really emphasize where my solutions are. So I want to look for the area that is shaded twice, the double shaded region. And that is where I'm going to put a S in a circle. That S in the circle stands for solution set. So this is all the elements of a complete full credit inequality graph. My boundaries have accurate solid versus dashed. My shading is in the right directions. I've labeled my solution set, and I've labeled which graph goes with which inequality. Underneath, when they say state the coordinates of a point in the solution, justify your answer, I'm going to choose any point in this double shaded region. So let's choose, for instance, -3, 2, right? That green point. -3, 2. I could justify this just by saying it is in the double shaded region, or I could justify it by substituting it into the inequalities and seeing that they make both true. So if I go that route, then the first inequality was 3y, so my y value is 2, plus 2x, my x value is -3, is less than or equal to -15. Three times 2 plus 2 times -3 is 0. 0 is indeed less than 15, so it makes the first inequality true. And then the second inequality, 2 minus -3, is greater than 1. 2 minus -3 is 5. 5 is indeed greater than -1. So this is a solution because it makes, or I'm going to say this point, makes both inequalities true. That is my justification that it's a solution. Any solution should make both things true. So that's the easiest way to justify, is just substitute it in. Whether it's an equation or an inequality, if it makes it true, you know it's a solution. And then our final one here, Courtney and her lattes. So Courtney went to a coffee shop to purchase lattes and donuts for her friend. One day, she spent a total of $15.50 on 4 lattes and 2 donuts. The next day, she spent a total of $18.10 on 3 lattes and 5 donuts. All prices included tax. If X represents the cost of 1 latte, and Y represents the cost of 1 donut, write a system of equations that can be used to model this situation. So system means I'm going to be writing 2 equations. The last question on the Regents, the 6-pointer, is almost always a system. And we get our first 2 points just by being able to write the system. So on day 1 is her first equation. So she has 4 lattes. That's going to be 4x. And 2 donuts, so plus 2y, was a total of $15.50. So 4x plus 2y equals 1550. And then on the second day, she got 3 lattes, so 3x, and 5 donuts, for a total of $18.10. I have written my system. Cost of donut, no, cost of latte. Y equals cost of donut. So at this point, this is worth 2 out of the 6 points. Now they ask me, Courtney thinks that 1 latte is $2.75 and 1 donut costs $2.25. Is Courtney correct? Justify your answer. So essentially, they have given me possible values of x and y. And they want to know if they make both equations true. If they're a solution, just like in the inequalities, it needs to make both true. So let's test it out. 4 times 275 plus 2 times 225. So I took my first equation and I replaced the x and the y with the latte price and the donut price that Courtney thinks. If I put this in calculations, I get 1550. So that means that those values work for the first equation. However, we don't know if they work for the second equation yet. So let's try them out in the second equation. Remember, they need to work for both to be a solution. So in the second equation, we want this to equal 1810. It gives us 1950. So, since this works in the first equation but not in the second equation, Courtney is incorrect. Only makes one true. Or I would say Courtney is incorrect. These values don't make both days true. So to be a solution, we need to make both true. And then the final step is use your equations to determine algebraically the exact cost of 1 latte and the exact cost of 1 donut. One thing to keep in mind is what we're going to do next is solve the system algebraically. However, we can figure out the solution graphically by graphing our 2 equations. Right, this was the first equation I wrote, and then the second equation I wrote. So there's my system. If I graph my system, why don't I see one of them? Ooh. I think I messed up that Y. There we go. If I graph my system, I can find the intersection. This tells me the intersection is when x equals 295 and y equals 185. So x was a latte. We know that a latte is 295 and a donut is 185. And we can put this down here and we can just tell ourselves this is the intersection. If that is the intersection, we know it's the solution. So even before we do the algebra, we know our end goal. Let's say you struggle with systems of equations. If you find this graphically and you say that that's the intersection, that would still earn you a 5 out of 6. So there's nothing wrong with using a different method if you know you're weak somewhere, as long as you know that you'll only get partial credit instead of the full credit. To do this algebraically, what we're going to do is we want to use either substitution or elimination. So my first goal is to get rid of one of the variables. I think I'm going to try to get rid of y. So the way I'm going to get rid of y is I'm going to multiply my top equation, the entire thing, by 5. And I'm going to multiply my second equation by -2. I chose those values because the result is we get 20x plus 10y equals 77.5. And then we get -6x minus 10y equals -36.2. So if I choose values such that I end up with opposite coefficients for one variable, I have 10y and I have -10y, now I can add my two equations together and that variable is going to cancel out. It's going to subtract to 0. So that will give me an equation that only has x's. So I have 14x equals 41.3. Divide both sides by 14. And I get 295. So we see that I've already gotten one of my values. I got that latte price. Now I'm going to take that latte price, substitute it back into either equation, and I'll use that to find y. So if I use my first equation, 4 times 295 plus 2y equals 1550. Then I can use this to solve for y. So 4 times 295. So this is 1180 plus 2y equals 1550. Subtract 1180 from both sides. And I'm going to get 2y equals 370. Divide both sides by 2. And I get y equals 185, which again was my price of a donut. So what's nice is using the grapher, I knew that a latte was $2.95 and a donut was $1.85, and then I was just working through the algebraic moves to prove that through a process to get my full credit. That brings us to the conclusion of the free response section. I hope this was helpful, especially in seeing how to use this calculator to your best advantage. And have a great rest of your day.